Everybody, we're going to solve a problem using Thevenin's equivalent circuit. So our problem, some of you have requested me to upload a video, so here it is. So what we have here is one power supply, two resistors, as you can see here, and one inductor. What we have to do is we have to find the current flowing through the inductor and the voltage drop across this inductor, right? And the current in this loop, right? I1, okay? So we can do this by using Thevenin's equivalent circuit. So we have to reduce this to this form. So now we have one power supply, that is Thevenin's voltage, yeah, and one Thevenin's resistance, yeah. So now to find the current, we can use this formula which we already know, yeah, and you also know what tau stands for. Tau is the time constant, yeah. So in the first equation, equation 1, Thevenin current is not known, and in the second equation we know the inductance but we do not know the Thevenin resistance, right? And the Thevenin the inductance is 5 millihenry. Yeah, you can see that. Yeah, that's given to you. So first let's find the Thevenin resistance, right? Okay. So to find the Thevenin's resistance, what we do here is we simply remove the inductor in the inductor in the circuit and make it a open circuit between A and B. Yeah, just like this. So now this looks like a parallel circuit. Okay, the R1 and R2 are in parallel now. Yeah, so you can find the equivalent resistance, and there you go. So your Thevenin resistance, you can simplify this and find the Thevenin resistance. So one equivalent resistance, which is 4 ohms here. Yeah. Now let's find the Thevenin's current. So to find the Thevenin's current, we keep the circuit open between A and B, and now we have to measure the voltage across the resistor R2. So the voltage across the resistor R2 is nothing but the open circuit voltage, right, across this, yeah, and this is the Thevenin voltage. So to find this, what we do is we use Ohm's law. So voltage across the resistor R2 is nothing but R2 times the current through it, yeah, using Ohm's law. So what is the current through this R2? We can use again the Ohm's law, yeah, B divided by R1 plus R2, because now these are in series, yeah. There you go. So now if you rearrange this equation, you will get something like this, right? R2 by R1 plus R2. And this looks like a potential divider, voltage divider circuit, right? Yeah. Now you can substitute the value of R1 and R2 and the value of voltage, and then you find the Thevenin voltage. So Thevenin voltage is equal to 3 volts. Now you can find Thevenin current using Ohm's law again, and there you go, you find the Thevenin's current. So you can find the time constant, substitute the value of the inductance, and substitute the value of the Thevenin resistance, and you find the time constant. Okay. Then now to find the current across the inductor, go back to the equation 1, substitute all the values, find the find the current across the inductor. Now to find the voltage across the inductor, you can use V is equal to L di by dt. Now differentiate this equation and you get, so differentiate the equation above and you get this. Okay, so now you substitute all the values and you get this. So that is your voltage across the inductor. So now you have found the voltage across the inductor, current across the inductor. Now you have to find I1, yeah, in the loop 1, yeah. So go back to this, the first circuit, and you have 9 minus 12I1 using Kirchhoff's law, yeah. There you go. Substitute all the values, yeah, and simplify it, so you get this. So now we have found all the unknown values. Thank you very much.